this graph can't happen in real life because you can't go from 54 to 24 at an instant. You could go pretty fast, you could hit your brakes pretty fast, but not at an instant. So, on your next, for that last question, it's kind of a trick question. You can put a question mark. There's not a good answer to that. The answer is that this graph is not feasible. So, what this should actually look like is more like this. We should have a smooth curve because in order to go from 54 miles per hour over here to 24 miles per hour over here, I've got to slow down a little more gradually. So the graph should actually look a little more like this. So these questions are the same as what we had before. So at 0.1 miles away, I could still use that same estimate that we did before, right? That slope is the same. This is the same graph. I just smoothed that curve out. So I could still say that I was going 54 miles per hour. Same thing over here at 3.5 miles from the, at 0.35 miles from the speed limit. I was still going 24 miles per hour. So this time, using calculus, or estimating what calculus would tell us, I can actually get an estimate of how fast I would have been going at 0.3 miles. So at 0.3 miles away, that's this point right here. What I can do at this point is use something that we're going to call a tangent line. So I'm going to play with this here. Let's make that dotted. And what I want, a tangent line, is a line that barely touches the graph at one point. I'd say that's pretty close right there. So, this line we can estimate was about my speed at that point, the slope of this line. Now, this is an estimate because we don't have exact numbers, we don't have equations. You guys don't know how to do equations of tangent lines yet because you haven't learned that far in calculus. But we could estimate here. So if we want to make an estimate for this, we could, nothing's really close. Well, that's pretty close to grid lines. Let's use that point right there. And that's not too far. Let's use that. So if I use this, we'll call that like 0.25 right there. So if I go from 0.25 up to 0.4, that'd be up 0.15. And then we're going to the right 15. So let's figure out how fast that would be. Hopefully it's going to be somewhere between 24 and 54. So again, remember for slope, even though you guys are masters of algebra, or I wouldn't have let you sign up for this class, you still might get your slope mixed up. Which one goes on top? Rise or run? Rise on top. Y, values on top, right? So 0.15 miles, 15 seconds. Just like the other one, we got to multiply that by the 3,600 seconds over 1 hour. And 0.15 times 3,600 is going to be 540 over 15, so 540 miles over 15 hours. And we get 36. Now, the cop had not been behind me till I got to that point. Might have been okay. I mean, I wasn't 20, probably about, well, yeah, I was in the, that was about where I saw those 25. So he might have had some mercy on me there if I was slowing down and just got to the 25. But unfortunately, I think we were more about right here whenever he saw me. And so I got to, thankfully, had not had a ticket in 3 years, reduced it to improper equipment. So my insurance didn't go up. But what the ideas we're looking at here are looking at ideas of rates of change before we learn calculus versus after we learn calculus. So before we learn calculus, we can really only find the rate of change of something that has a constant speed, right? So like in this stretch where I'm going 54 miles per hour and my speed's not going up or down, I'm staying at that speed. We could use pre-calculus math to find that. But whenever we're not talking about something constant, when we're talking about something changing, that's when calculus comes in. Because I needed to know that speed at that moment, and it wasn't just a straight line. So that is something that calculus can be used for. I've had 2 tickets in my life. Let's go to the other place that I got a ticket. I've only had 2. I've been driving for 21 years now, and I've only had 2 tickets. It's not the worst record in the world. Although I hate to admit this one's very similar to the last one. Because this you're probably more familiar with. This is just 268 right back here, going by, John Boys is up here, Pleasant Hill Daycare is back here. Anyway, I used to not go this way very much at all when Hunter was in daycare he went to daycare out in Trap Hill. So I was coming from central office, so I went this way, and I never went this way. Some people agree, this is a little bit of speed trap if you're coming down the hill. I must admit I was going up the hill, which makes it a little bit worse. If I'd been going down the hill, I'd feel a little bit more justified in my speeding, but I was going up the hill, and I was not paying attention to anything, and I didn't ever go that way, and I totally overlooked this 35-mile-per-hour speed limit here. So, once again, in a 35-mile-per-hour speed limit, I was going 50-some up through here. I got up here to the top of the hill and looked in my rearview mirror, and there are blue lights. This was actually the first ticket I got. The Dobson one was the second ticket. You'd think I'd learned my lesson, but I don't guess I did. So, I've learned it now. Maybe.
Next year,
I guess. If she said so. I'm recording, so you can go back and watch it. So, let's look at a similar scenario, but in a different form. Okay? So, this was my route to go pick up Hunter. And I want you to read these questions and answer them based on that graph. Okay, so I'm going to give you a couple minutes, or a couple seconds. Let's go somewhere between a couple minutes and a couple seconds. Let's go about 30 seconds to read those. Take a quick estimate. I just want a quick estimate. You won't get an exact answer. You don't have to, figure out my speed. Just... Okay, so we'll notice this is similar to the last graph in that we've got time on the x-axis, distance on the y-axis. So you always have to pay really close attention to that. We're going to look at some that are not that way soon. So, was Miss Hyatt traveling at a constant speed over the interval shown? So over the whole interval from 0 to, what does it go to, 130 seconds. was my speed constant that whole time? No, it was not. That's a definite no, because if it was constant, what would the line look like? Straight. Straight as an arrow. Now, it's not super curvy, but it's not a constant speed. All right, so during what time interval was I driving the fastest? Who wants to tell me that? What do you think, Lily? 130? That is not the answer. That's when I had gone the furthest. If this side right here said speed, that would be true. What do you think, Lydia? About 50 to 100? Okay, why do you say that? Steepest. That's what we're looking for. So anywhere in here, I would say about 50 to 100 seconds. That's where we're looking at. Now, the reason we're looking at steepness and not just how high is because on this axis, we just have distance. So when we're looking at speed, we're thinking about distance divided by time. That's what gives us speed. And distance over time is your change in y over change in x, because we got distance here, time on our x. So it is our slope is what we're looking at for this. Your answer to that question, Lily, is going to be correct on some of the other graphs that we look at. So keep that in mind, that sometimes it is true that like the highest point would be our highest speed, but it's not on this graph. So anywhere from 50 to 100, somewhere in there. During what time interval was Miss Hyatt traveling the slowest? Who can tell me that one? Take a guess at it. 100 to 130, I'd say so. And I would maybe even go, if you want to go 120 to 130, that's definitely like, if you want to go one tiny segment, I think that's the least steep. So 120 to 130 seconds. And that is when I was slowing down to stop at the stop sign. I would like to say I saw the blue lights, but I didn't see the blue lights, so I was already stopped at the stop sign, and I was like, oh gosh, they forgot me. So this is whenever I was going the slowest. But you can kind of see it's not very steep here because you can't start at 45 miles per hour, right? You have to start off from 0, so you're going slowly at first, then you speed up, then you have to slow back down. All right, so I have made an approximate table that goes with those numbers right there. So we are going to use that for, can I make this, will it go over, oh yeah, okay. I'm going to have you guys do this from the table. I want you to estimate my average speed for the trip, for the whole trip. Estimate my speed 20 seconds after I leave the central office, so that'd be right here. And then estimate my speed 65 seconds after I've left central office. Okay, so you got this to use and the graph. You can use either one, whichever you want. I'm going to give you a few minutes to make an estimate on those. Yes? Let me get you some batteries, because I put batteries in those and checked them before. Even though I take the batteries out over the summer so that they don't get corroded just sitting there. So maybe they were already about to die. Let's see if we can work. Do those new batteries work? Okay, good. So we got 7,530 feet over 130 seconds. So just like the last problems we were doing, we need to change seconds to hours. So we're going to do 3,600 seconds over 1 hour. And the reason we're doing that, seconds are on bottom here. They're on top here, so they cancel out. It changes it to hours on the bottom. We need to do something similar with feet. Feet need to be changed to miles. So feet are on the top of this fraction, meaning we need to put feet on the bottom here, and we want to change it to miles, so we'll put miles on top. How many feet are in a mile? Good. 5,280 feet are in 1 mile. So what we're doing there is like we're really just multiplying by 1 because a mile and 5,280 feet are the same thing, right? And so when you multiply something by 1, you don't change its value, but we convert the units by doing that. So feet here are canceling out with the feet on the bottom. Notice the only units you have left on top are miles. The only units you have left on bottom are hours, so you're getting miles per hour. So then, to multiply fractions, we just have to multiply straight across. So we're going to do 7,530 times 3,600, which is going to give us that huge number. And then we got to do 130 times the 5,280. Oops. And we're going to get 686. All right, so we got to divide those two numbers. And we're going to get 39.493 miles per hour. So this part right here that I use to convert from feet per second to miles per hour, you would do that every time to go from feet per second to miles per hour. So I'm going to give you a little longer to look at the last two questions to see what you're getting there. I think I have a class with Troy next. I know how you got how many even been to those classes to know what you have. I got an extra, so take one. Okay, take it and give it to Troy. check with your neighbor. See if you guys are getting the same numbers. I know some of you are still punching buttons, so you might not be quite done. Hello? Uh-huh. Hyatt.
Not the
That's okay. Never mind.
You subtracted, right? And then divided and then added.
Oh, look, Troy's back. You can give it back.
You get homework. Yay.
All right. Okay. What are we getting for our answers for that second question?
31.75.
31.75?
Miles per hour, yeah.
31.75? Are you guys getting 31.75?
705.
705?
Yeah.
Okay, that's not a good estimate. It's not, but that's what I expected you to do.
I knew it.
So, did you tell me what you did, Jeremy, to get that?
I took 930 divided by 20.
930.
Yeah. And then I multiply 3,600 over 5,280.
Right, and I'm gonna skip writing that part out for sake of time. And you said you got 31.705.
It's a big number, but yeah.
Yeah, we'll just go to the answer. It's fine. I'm gonna trust you there because it sounds like other people are getting that answer too. So this is not the best estimate because what Jeremy and most everybody else, I think, has found. Did most everybody do it this way? It's what I expected you to do because you don't know calculus yet. So what you have found is you did the distance. Oh wait, no, went too far. Oh wait, that should be 20 right there, shouldn't it? Yeah, I wrote it wrong. 20. So we did the distance that was traveled over the first 20 seconds, the whole 20 seconds, right? So what you found was the average speed for that first 20 seconds. Now, were you going fast when you very, very, very first started off? No. Or, well, was I going fast? I was not, right? Because I was stopped. So I had to speed up. So I was going slower right here than I was right here. So this is my average speed for the first 20 seconds, but it's probably actually a little lower than my actual speed, like my radar gun speed, my speed at that very moment, right? Because whenever a cop is looking at how fast you are going, they're like, well, you were speeding, ma'am, but your average speed over the last 3 miles was okay, so you'll be all right, right? They just get you with a radar gun, and if you're speeding, then they've got you. So this is average speed over the first 20 seconds. It is not the best estimate of the speed at that moment. We would really see it if we had time whenever we looked at the speed at 65 miles per hour. It would be a lot slower than the actual speed because we're not going that fast here. We're only going like just over 30 here at the very beginning. But over here, we all know that I got a ticket, so I was going faster than that, right? So we don't have time for me to go into what exactly you would do for this. So we're gonna table this, and we're gonna start with this tomorrow. But be thinking about another way that you might get a better estimate of that time. Now, you do have homework. I've given you a piece of paper that says what is calculus. I believe it's page 58. Well, you're going to need to look at like 58 through 63 or something in your book. So you either need to take your book or take pictures of all of those pages And there's just a little bit I want you to read that first page, and then there's a couple of pages of pictures and graphs that you're going to look at and answer those questions for me. That's going to be your homework for tonight. So it is okay. It's not necessarily directly related to this, so it's fine that we didn't finish notes. That just gives you sort of an overview of what we're going to be looking at. Don't spend too much time, like, really worrying about that. I just want you to get an idea.